Welcome back with another tutorial of a problem, physics problem, and this one we're gonna solve it. It has to do with a graph of volt relation to the time microsecond. So just before the answer the questions, I'm gonna take out the information that I have from the graph from time that is equal to 0 second, the current, the volt capacity, the voltage is 0 volt. Okay, and when time equal to 1 second, the voltage is 100 volt. And when time equal 2 second, the voltage is 0 voltage. And when time equal to 3 second, the voltage is 50 volt. And when time equals 4 second, the voltage is 0 volt. So this is the information that we have from the graph. Actually, it's microsecond. Don't forget, this is microsecond. Okay, microsecond. So 1 microsecond is equal 1 times 10 minus 6 second. We can convert this later on the information. So now the question is, we have a capacitance. Okay, now we're going through we have a capacitance of 0.1 microfarad. That's means 0.1 times 10 minus 6 farad. And we have to draw a graph for displacement currents through this capacitance of time. So we have to draw a graph from displacement current in relation to capacitance of time. Okay, so if we take this is the formula of displacement currents, and it's equal capacitance multiplied by differential voltage divided by differential of time. If time equals 0 second, meaning that the current is 0 amp. And if time equal 1 second, current will be equal to 0.1 times 10 minus 6 farad multiplied by 100 volt minus 0 volt divided by 1 times 10 minus 6 minus 0. And current will give us 10 amp. And if time equals to 2 second, current will be equal to 0 amp. And if time equal to 3 second, currents current will be equal to 0.1 times 10 minus 6 farad multiplied by 50 minus 100 volt divided by 3 times 10 minus 6 minus 2 times 10 minus 6. And currents will be equal to minus 5 amp. At a time that is equal to 4 seconds, amp will be equal to 0 amp. So now we can use this information to build a graph. So let's say okay, so let's say this is 10 amp, here 5 amp, 0 amp, minus 5 amp, minus minus 10 amp, this is the time by microsecond, and this one is side is currents. So when time equals 0, amp equals 0. Let's put the 1, 2, 3, and 4 microseconds. When time equals 0, current equals 0. When time equals 1, the differential of time is going to start from 10 amp and it's going to be equal to 10 amp of 1 microsecond. When time equals 2 seconds, amp equals 0, so it's going to go down here and it's going to go to 2 seconds here. When time equals 3, current is minus 5, so it's going to go down here and it's going to go to 3 seconds. When time equals 4 seconds, amp equals 0, so it's going to go up here and it's going to go equal 0. And this is how we do the currents in relation to the time comparison.